1. Alright, and welcome back to the last video of the homework series for section 4.4. 4.4 is the last chapter we're covering in the book on the introduction to trig. So we're going to go look at the last problem. Here in question 7, it's asking you to solve for theta in the specified domain. So each problem will give you a specified domain. Some of them in the old format, some of them in the new interval format. Give solutions as exact values where possible. Otherwise, give approximate measures to the nearest thousandth. So they're talking about if it's degrees, thousandths of a degree, if it's radians. Alright, so the question we're doing today is going to be secant squared theta minus 2 secant theta minus 3 is equal to 0 for the domain where theta belongs to negative 80 to positive 180. Note the square and rounded bracket. So let's go on and see what we can do with this. So in this particular situation, we're going to have, well, it should be secant squared theta minus 2 secant theta minus 3 equals 0. So what we'll end up having to do is find a set of domains that'll answer this question. So what this really is kind of a factoring problem. So what I would say first is let x be secant theta. I discussed this approach in an earlier video, so I'm going to employ it here to make it easier to follow what I'm doing. So if I let secant theta equal x, then what this becomes is x squared minus 2x minus 3 equal to 0. And this is a really simple factoring problem that we do in grade 11. So let's see what we would have for this. So again, it's x squared. So I know I'm going to have two possible solutions. So let's start by making two sets of brackets here. And these will all be equal to 0. So the first one, let's just pop in some x's. And I want to know what values can I pop in here that when I multiply them back together, I'll get this original problem. Well, 3 really only has two factors, 1 and 3. So we'll put 1 in one situation, and we'll put 3 in the other situation. So here I have negative 2. So this means that I'm going to go to negative 3 and increase by 1. So let's make negative 3 plus 1. Because if I have negative 3x plus 1x, that'll make negative 2x, and negative 3 times plus 1 is just 3, so those should all work out. So if you had an issue following what I was saying there, let's just check now. Let's see. So x times x is just going to be x squared minus 3x plus 1x minus 3 equals 0. And if we add it up, it's x squared minus 2x, because 3x plus 1x is negative 2x, minus 3 equals 0. So this is a check, right? So this is just saying, maybe I'll even do a check here so we know that that's what I was doing, right? And it worked out. This matches that, so these factors are correct. So this means that when we're working on this, let's go pop secant theta back in for x. So secant theta plus 1 and secant theta minus 3, and these all need to work out to 0. So now I need to figure out in what scenarios does secant theta plus 1 equal 0 and secant theta minus 3 equals 0. So what we're asking for, what are the zeros for this graph, if you're going to graph it out. So the first one, secant theta plus 1 equal to 0. Well, that's pretty simple. That's just going to be secant theta equals negative 1. And then the other one, secant theta minus 3 equal to 0 becomes secant theta equals 3. So secant theta could be secant theta could be -1, or secant theta could be 3. So those are the answers to this kind of situation, and what it wants us to do now is figure out what would the trigonometric values of these two things be. So let's go take a look at those. So I'm just going to clear this part of work so we can go on to the next part. Alright, so here's the second part of 7D. So in the last video we found the answers could be secant theta equal to -1 or secant theta is equal to 3. So to do those, we need to know that secant theta is equal to 1 over cos theta and that cos theta is equal to x. So if I'm dealing with the first one, let's take secant theta equal to -1. We're going to be wanting to find out where is the x value equal to -1. So our negative x's are here and here. So using our knowledge from down here, I know that -1 is going to have to be equal to 1 over cos theta. Or what I can do is just combine this knowledge so that secant theta is equal to 1 over x. So 1 over x, therefore, is going to be, so cos theta is going to be 1 over -1, which means I'm talking about an x value of -1. So I'm sitting here 180 degrees. So now this could be either, as I found, the standard one would be -1 will give us 180 degrees, but we could have this as an answer too, right? -180 degrees. So now we need to figure out which of those two answers is valid within our response. So remember that our system was theta belongs to -180 inclusive. So square bracket 180 degrees, comma 180. So 180 degrees is not a valid answer. So this one won't work. So only the -180 will work. So one of the possible answers we have so far is going to be that theta could be -180 degrees. Okay? So the theta that'll give you -1 is -180 degrees. So if you take secant of 180 degrees, you'll get -1, or you could say that cos theta is equal to 1 over -1. So again, cos theta of -180 degrees will give you the same response. So that's what's going on there. So let me clear this up, and then we'll go on and talk about secant theta equal to 3. So secant theta equal to 3 is the next one we need to consider. And this would be where cos theta is equal to 1/3. So we want to know where is cos theta equal to 1/3. And remember that cos theta is dealing with the x direction. So we can go through and take a look and see if any of them give you in terms of 1/3. Cos theta is equal to x. So you can take a look, see if any of them give you 1/3. If you take a quick look through, you'll find none of these have 1/3 in the x coordinate. If you need to remember, those are x and y. So what you're going to have to do is plug this into your calculator to find what's theta. So if you plug that into your calculator, theta should wind up being -70-ish. So let's take a look at what that would be. So clear. So 1 divided by 3 is equal to this. And we're going to be talking about degrees. So let's pop that back in degrees. And if I do shift cos of that, we'll find it's 70.53. So this system here is going to be 70.53 degrees. So 70.53 degrees is going to be greater than 60, less than 90. So this is up here somewhere. So we're talking about this triangle here. Okay, so this would be 70.53 degrees. And this is a positive x, so that'll work too, which means that our other one is going to be here in quadrant 4. So it could be positive 70.53 degrees or negative 70.53 degrees, right? Because we're just taking it in both systems. So now we just need to double check, can I go past 180 degrees and get to this one when it's just past 270? So if you remember, theta belonged to negative 180 degrees and positive 180 degrees non-inclusively. So that means that you get to go once around this way. So you're only going to hit this triangle, and then you get to go once around this way. So you only hit this triangle. So these are your two solutions. So the final set of answers is we're going to get minus 180 degrees, negative 70.53 degrees, and 70.53 degrees are our answers for this situation. So hopefully you found that useful, and that's the last of the examples for homework in question 4.4. So remember to refer back to the videos if you're ever having issues with particular homework questions. And other than that, I'll see you in class, or I'll see you in the next video.